In Puerto Rico, disaster strikes an iconic space telescope.
I took a few steps and I heard everyone screaming. The dome was completely crushed.
Tragedy as a high-rise construction project in Virginia crashes to the ground.
You had a building that was still wobbling. There were still pieces falling from the upper floors.
In the UK, a rural roadway is mysteriously destroyed.
It was like a war zone. It was absolutely horrendous.
And catastrophe in Georgia as a ship takes down a bridge.
We tried to warn them, get out of your car, run.
With big builds, even the smallest fail can trigger a huge disaster. From miscalculations to misunderstandings, or just plain bad luck. These catastrophes are every engineer's worst nightmare. Engineers often strive to build bigger, better, and bolder than ever before. But sometimes reaching for the stars can end in a crash landing. Like this fail in Puerto Rico, the catastrophic collapse of a trailblazing structure.
This huge plume of smoke, it was unreal.
An out-of-this-world telescope that came crashing down to Earth.
These people had been working there their lifetimes, and it was over, collapsed.
Dramatic destruction that laid waste to a pioneering space project.
This iconic structure even featured in a Bond film finale, but this time the disaster played out for real.
How could this happen?
More than 1,500 kilometers off the coast of Florida, in the Caribbean Sea, lies the tropical island of Puerto Rico. First colonized by the Spanish, for more than 100 years, it's been a US territory.
When the Spanish explorers reached Puerto Rico more than 500 years ago, they called it the Rich Port. It was named after its plentiful natural resources, including an abundance of gold.
Hidden deep within the island's rainforest lie the remains of a mighty American-made resource that is anything but natural. For 50 years, the Arecibo Observatory was home to the largest radio telescope in the world. For receiver engineer Felix Fernandez Rodriguez, landing a job here was a childhood dream come true.
I was born and raised here in Puerto Rico. So most kids, they make field trips to Arecibo, right? And then I actually got hired. And I said, okay, so I was like a little kid. I felt, blessed to be here and proud to be here as an engineer and as a Puerto Rican, just to be working on such a big instrument.
The telescope was first operational in 1963, but it didn't actually look into deep space. It listened.
The Arecibo dish is what's known as a radio telescope. Instead of visible light, it detects radio waves being emitted by anything from distant stars to planets, and even asteroids.
From finding ice on Mercury to producing the first radar maps of the surface of Venus, and even discovering organic molecules in a distant galaxy 250 million light-years away. Arecibo has been at the forefront of space exploration for decades. As forensic engineer John Abruzzo explains, one of the most powerful radar installations on Earth wasn't there simply to serve, but to protect as well.
Because they could see in deep space, and they felt that there was something on a trajectory coming to the Earth. They could track asteroids as part of the planetary warning system.
Key to its super hearing was its super size. A concave dish 305 meters in diameter with an area roughly the size of 15 football fields. It was covered with more than 38,000 perforated aluminium panels to act as a giant reflector, focusing radio waves up to a 900-ton receiver platform held in place by 18 cables, each made up of over 150 individual steel wires, attached to 3 huge reinforced concrete towers. So how did this one-of-a-kind construction exploring new frontiers come to be in the middle of a jungle on a tropical island?
If you're going to build a 1,000 feet diameter dish, it would be a major engineering challenge. So what about if nature provided you with a hole, right?
This part of Puerto Rico is prone to sinkholes, and engineers found one about 16 kilometers south of a city called Arecibo, and it was the perfect fit for their giant dish.
A giant crater concealing a supersized telescope. It's like something from a sci-fi movie.
It was even used as the hideout for a James Bond supervillain. But this special project and star of the silver screen was about to be dealt a devastating blow, where it would be shaken, not stirred, to its very core. August 10th, 2020, 2:36 a.m. A main cable on one of the towers supporting the suspended platform suddenly snapped.
The telescope was quickly shut down, while forensic engineers were flown in to assess the damage.
While the team was investigating, a second cable also failed. A concerning development, as lead investigator John Abruzzo explains.
Prior to that cable failing, we could argue that we had enough strength and enough cables supporting the platform. Now, if one more cable goes, the platform will fall.
A month later, on December the 1st, a drone was sent up to monitor the dangerously unstable platform. Receiver engineer Felix Fernandez Rodriguez had just arrived at work.
I came in, went to the cafeteria, I took a few steps and I heard everyone screaming.
This is why. At 7:54 a.m., a third cable gave way.
I could see the whole structure just swing by in front of my point of view.
The entire suspended antenna fell around 150 meters in seconds.
Around 900 tons of platform crashed down onto this huge but highly sensitive dish.
Like a giant wrecking ball, it took everything with it, even the remaining cables and the tops of the support towers.
The dome was completely crushed, almost like a pancake.
For workers like IT manager Arun Venkatraman, the devastation, like the telescope's targets, was out of this world.
Dust spewing all over the place. It was like a movie scene.
This huge plume of smoke washing over where everyone was standing.
While thankfully no one was hurt, for some, a lifetime's work was left in ruins.
You see the stubs of the 3 towers and no platform, and it just comes as a shock.
For us that we worked there, it was a part of the family. We had that pride in it. So seeing that, unfold in front of us was really hard, to be honest. Everyone here in Puerto Rico was like flabbergasted. Like, how could this happen?
Islanders and scientists around the world wanted answers. The telescope had stood for over 50 years. So what had caused the structure to fail now? After examining the wreckage, the supporting cables appeared to be unbroken.
Cables support some of the longest bridges and tallest structures in the world, and the cables themselves rarely fail. So here something else must have gone wrong.
From footage taken by the drone inspecting the top of a support tower, engineers saw that the third cable slipped from its connection, known as a socket. The question was why?
This structure was built before the first moon landings on a tropical island in the path of regular hurricanes. So one key suspect was decades of exposure to high winds.
John Abruzzo was the lead investigator.
What we determined from our investigation is that certainly extreme winds play a role in the failure of this telescope, the collapse, because you're basically pummeling the platform with these very high winds. It's kind of bouncing a few feet up in the air as it's suspended. And all of that puts stress on these cables and kind of accelerates that slip between the cable and the anchor.
In this case, the anchor was a lump of metal, formed by splaying the ends of the cables, known as brooming, before pouring molten zinc over them. Pierre Gisbane investigated the failure.
The cable is placed inside the socket, the wires are broomed out, and then zinc is poured between those wires to form a solid plug that locks the cable in the socket.
Here, the brooming was done manually, which was common practice on cable structures when Arecibo was built.
What that means is that each connection or broom is unique, and so each socket has a different ability to resist the pull from the cables.
It turned out that the cables that failed first were relatively weaker due to how the wires had been broomed. And there was another problem. After years of enduring high winds, the zinc that held the wires in place was slowly losing its grip.
Zinc, like concrete or like wood, it creeps. So what that means is over time, it tends to deform.
We determined through our analysis, because of the zinc material creeping or flowing or deforming inside the socket, the cables were allowed to slip out and eventually pull out of the sockets completely.
Although there were no high winds on the day of the failure, the years of slipping finally took their toll. And once the third cable broke, it set off a chain reaction, and the giant receiver crashed to Earth. And while the suspended system was designed with some built-in redundancy, in the end, it simply wasn't enough to save the structure. After the collapse, a massive cleanup operation began to clear hundreds of tons of debris. Today, the ruins serve as a constant reminder of a one-of-a-kind construction that advanced space exploration for more than half a century.
What we need to learn and preserve is the inspiration from having a big idea. I will not have bad dreams about the collapse, but I will try to imagine the dish as it was living and producing science.
Now, plans are underway for the observatory's future, with a world-class facility to serve as a centre for STEM education and research. A fitting legacy for such an inspiring icon from the history of science.
Every time I come down here, I think humans can do amazing things, right? And we put our passion, our efforts into having it working as best as it could for the longest time. I am convinced that we can do many great things still with Arecibo if we have the conviction to do it.
In engineering, no matter what you're building, it's crucial that you stick to the plan. Any deviation can have catastrophic consequences. Like this tragedy in Virginia that crippled a high-rise construction project.
The crane operator jumped as it was falling.
As the entire structure was ripped in two.
A section of the stairwell where a climbing crane had been was gone.
Revealing a devastating engineering failure.
One slab comes down and hits the next slab and hits the next slab and hits the next slab.
This structure was intended to bring a community together, but it ended in tragedy.
People will always remember exactly where they were when they got the bad news.
In 1790, the United States capital, Washington, D.C., was founded beside the Potomac River, on land donated by both Virginia and Maryland.
Washington, D.C. has always been a hotbed of politics, finance, and culture. But like most capital cities, smooth operations depend on hordes of commuters coming in from the suburbs.
Suburbs like Bailey's Crossroads in Virginia, just west of the Potomac, became popular in the post-World War II era. Charlie Clark is a local journalist.
The Pentagon was built in 1943 and 4, and so there was a new need for a commuting highway to the Pentagon and housing for the workers in subdivisions of Northern Virginia.
In the 1960s, plans were being made for this office, retail, and residential complex, known at the time as the Skyline Center.
So Skyline was aimed at baby boomers who had their first paying job and were ready to make their first purchase. So they would advertise the Skyline as a place where you can meet fellow young people.
The complex would have 8 residential towers, including this one, Skyline Plaza Building A4. Designed for more than 400 apartments, the 26-story tower would be constructed using a fast, efficient technique. Kim Roddis is a professor of engineering.
The way that the Skyline Plaza structurally is put together is what's called a flat slab system. And the floors you can think of as just like a tabletop. And the columns are the legs. And what you can do to make a high-rise is you can just stack the tables on top of each other. It's very efficient, and you want efficient design because that's what makes it affordable.
By early 1973, the tower was climbing high over Bailey's Crossroads. But things were about to take a dramatic turn. March the 2nd. Workers were pouring concrete for the 24th floor of the new structure. Volunteer firefighter Russell Ridgway was nearby.
I was dropping off my girlfriend at her parents' apartment, which was across the street.
Russell was distracted by a loud noise.
I thought it was a military jet that went over, but when I looked up, there was nothing there. So I come walking around the corner and could see nothing but dust and everything flying.
The center of the structure had totally collapsed, slicing the building in two. Dennis Call, then captain of Bailey's Crossroads Fire Department, was one of the first on scene.
What I saw is a section of the stairwell where a climbing crane had been was gone.
Journalist Charlie Clark also witnessed the carnage.
Just a kind of a shell of a building with curved sidewalls instead of rectangular, horizontal ones.
You had metal, concrete, wood, so you had a lot of debris and stuff and all there.
Chaos on the scene. You know, at that time they were in a search and rescue operation.
But the danger was far from over.
There were still pieces falling from the upper floors down into the center part area.
Meanwhile, the remaining structure appeared unstable, constantly interrupting the rescue efforts.
You had a building that was still wobbling. Everybody's got to take and get out and get to a safe area. Then when the coast was clear, then everybody took and moved right back in to the area that they were working.
Recovery efforts continued for weeks until the last body was found. More than 30 workers had been injured, and tragically, the collapse caused 14 fatalities.
Lives were lost. Somebody comes to work that day expecting to go home to their families, and the next thing you know, you get a phone call saying, they're not coming home. You know, I mean, you know, what's the family to do?
At the local level, people who witnessed it or heard about it right away remember exactly where they were when they got the bad news.
Within hours of the collapse, OSHA investigators arrived on the scene. The first concern was a crane that had been attached to the structure.
You had a crane that they used to take and bring the materials up, and that's where it had collapsed. Well, all that had fallen right down into the center part.
Professor of Engineering Kim Roddis knows the case.
You're immediately concerned about what's going on with the crane when you're looking at a collapse situation. Because if the crane is improperly set or improperly used, it can often instigate a failure. So that's someplace that you look at immediately. They did. In this case, the crane was not a contributing factor. Or more clearly, it wasn't the crane's fault.
As they dug deeper, investigators discovered a problem with the construction technique.
The single thing that most initiated that failure was the fact that they pulled the shoring out from underneath the 23rd floor.
The shoring poles were key to supporting the concrete as it hardened. But here, for unknown reasons, they had been removed or stripped earlier than planned.
Ordinarily, we have two strengths that we think a lot about as engineers. One is the 7-day strength, which is very important for construction. And that's very often when you can strip. The other is the 28-day strength, and that's called the design strength. And that's the one for when you can put it in service.
But at the time of the failure, the 23rd floor concrete hadn't yet reached its 7-day strength. And what's more, the cold spring weather was slowing the curing process.
When you pour concrete in cold weather, the chemical reactions that strengthen it slow down. The concrete can take longer to cure and potentially be weaker.
But the problem is that the floor below was only 4 days old, and it was cold. And so it's not anywhere near its strength.
With a flat slab structure, the floors suffered a failure known as punching shear.
This is going to be the 23rd floor. This is the column right underneath the 23rd floor. So when the load comes off of the shoring, so we strip out the shoring underneath, and now what's going to happen is I have to put all that load, has to flow through the slab. So I push the slab down, and what happens is the column punches through.
As the concrete was poured for the 24th floor, the lack of shoring and weakness in the concrete meant the 23rd floor was unable to support the load above.
It could have carried its own weight just fine. The problem was you were asking it to carry twice its own weight. And that's what brought it down.
This explained why the slabs collapsed. The crane was just an innocent bystander.
As the building collapsed, we're having this pancake failure where one slab comes down and hits the next slab and hits the next slab and hits the next slab. Eventually it gets down to a level that the crane is based on. Cranes are heavy. So what happens at this point is the crane starts rotating and coming down, and it tears a big piece along with it as it falls.
"16 months after the collapse, construction restarted. This time, with lessons learned from the tragedy, the tower was completed in 1977.
Hopefully they learned a big lesson, real big lesson. I'd only been a firefighter for about 2 years, but it was the worst disaster that I've ever seen. It sticks in my mind. You know, it won't be forgotten.
The tower still stands today as a reminder of the burden engineers carry with every structure they build.
It's a scary thing about being an engineer. There's a lot of responsibility. You can rebuild a building. You can't bring somebody's family member back.
When they build big, engineers try to prepare for any eventuality. But some failures just can't be stopped. Like this catastrophe in the UK, the dramatic collapse of a crucial connection.
There was nothing left of the road at all. It was like a war zone. It was absolutely horrendous.
A vital artery that had lost its way.
I was very shocked what had happened, why it had happened, and how we resolved the situation.
And a rural route that became the road to ruin.
This wasn't just a bump in the road. This highway was completely destroyed.
The county of Wiltshire in southwest England is an ancient land steeped in history.
Wiltshire is home to ancient cathedrals, giant horses carved into the chalk hills, and the iconic Stonehenge, which is believed to be more than 4,000 years old.
Publican Brendan Watkins is proud to call Wiltshire home.
It's a lovely place to live. You've got charming little medieval villages, little ancient towns, beautiful rolling countryside, away from the noise and the dirt of the city.
For centuries, this rural county has been connected by a network of small country roads. One road that's vital to Brendan and his hospitality business is the B4069.
The B4069 is the main thoroughfare. It's a busy road that takes all the traffic, and the Peterborough Arms is situated in the middle of this.
But for the pub and the more than 5,000 vehicles that use the road daily, getting from A to B was about to take a dramatic turn. February 2022, Storm Eunice was battering Western Europe.
Storm winds were reaching 200 kilometers an hour, the strongest gusts ever recorded in the UK. And for their own safety, around 20 million people were advised to stay indoors.
The storm wasn't just a danger to people. The torrential rainfall was saturating the ground around the B4069, and the road was struggling to cope. Highway engineers like Jack Francis were put on high alert.
The road began to experience severe cracking and bulging, with also tree movements that were sort of unnatural for this area.
There was large bumps on the road and cracks started to appear. It was deteriorating every day. The cracks were getting bigger, the bumps were getting larger.
This wasn't just a minor bump in the road. In some places, it had buckled by more than a meter.
It was quite obvious that this was going to get worse and worse until in the end just completely fell away.
On February the 17th, the vital roadway suffered a sudden landslide.
The road had completely disappeared down the side of the banks, and you couldn't even see the road in places.
It was absolutely horrendous. It was like a war zone. It was absolutely devastation.
With traffic cut off, Brendan's business was in the middle of an exclusion zone.
It was absolutely terrifying for us because this road doesn't look like it's ever going to reopen.
With the link severed, the community and local highway engineers wanted answers.
What had happened, why it had happened, and how we resolved the situation.
We've had storms up here for years, but we've never had the devastation of what's gone on up there now.
Civil and geotechnical engineer Dr. Cormac Reel also found the scale of the devastation puzzling.
When I first saw the images of the landslide, I was quite surprised by the size. First of all, it looked more like an earthquake zone than anything you would expect on a road network.
Local government and highway engineers launched an investigation, but with 150 meters of highway broken apart, piecing together the evidence wouldn't be easy.
The site, unfortunately, is unsafe, so we've had to utilize technology in the form of drones to assess the site and monitor the landslip.
This was kind of like trying to solve a jigsaw puzzle, where some pieces have slipped under a chair and others are missing altogether.
It turns out that engineers knew that something might be wrong with this stretch of road before it collapsed.
The landslide that destroyed the road might have been sudden, but in the weeks leading up to the collapse, there had been signs that trouble was brewing.
We first noticed signs of movement in the first week of February. It was closely monitored and inspected daily following those first inspections.
That movement explained early cracks in the surface, yet the culprit behind the ultimate failure could come down to the specific combination of geology beneath the road.
You can see from Wiltshire's giant horses that this whole area is chalky, which drains well. But where the road failed, another material was involved, which is famous for becoming waterlogged: clay.
Clay is made up of tiny soil grains. Now, although they're densely packed, there are pores or gaps between the grains, and when it rains, they can quickly fill with water.
If you get too much water in that pore space, then the soil starts to weaken and can fall apart. What we saw at this site was very heavy rainfall before the failure occurred.
As that rain soaked through the chalk into the clay, it sowed the early seeds of disaster. Then Storm Eunice struck, becoming the biggest storm to hit the UK in over 30 years.
We believe the weather has played a part in the landslip. Certainly the land first started moving following several significant weather events.
The landslide took 4 to 5 weeks from the first crack until the complete destruction of the road.
But the road had withstood worse storms before. So there was one remaining mystery. Why, after centuries of stability, had the ground moved now? Some questioned whether a recent development nearby may have played a part.
In the field above the landslide, there was construction work going on at the time. Now, this is not to say that this construction work is causing the landslide, but there was a number of things that changed that might have contributed. There was significant removal of vegetation, and there appears to be regrading of the slope.
Trees and plants don't just suck water from the earth. Their roots create a mesh that binds the soil together. It's well known that removing trees can weaken sloping ground.
In similar landslides, we've seen that this can contribute to the failure. The trees are removed, and those trees are drawing down a lot of water. When they're no longer drawing down the water, then the slope can become more unstable.
While the investigation is ongoing and the cause remains a mystery, for now, locals are stuck living near a road to nowhere. Before extensive repairs can begin, officials still have to check and analyse every part of the damaged road, which is challenging when there's no safe access.
We needed the ground investigation results to understand why the landslip has occurred in the first place, how we rebuild the roads, and also for future knowledge of the road if we have any future landslips to understand how this road, what it's built upon.
The ground needs to be stabilised and new drainage installed before the road can be relaid. A huge repair bill that could run into millions of pounds.
This is a large engineering scheme for Wiltshire Council to undertake. This is over 150 metres of road that needs to be completely rebuilt safely to ensure that hopefully it doesn't happen again in the future.
With repairs expected to take around a year. For now, this quaint country route has to live with the dubious title of Wiltshire's wonkiest road.
It's going to be like Christmas all over again when that road reopens. There'll be going to be so many relieved people in the area. It's going to be unbelievable. The villagers around here are going to be so happy. We're going to get our trade back and everything will get back to normal again.
When building big, engineers try to consider every possibility. But sometimes they're blindsided with catastrophic results. Like this disaster in Georgia, as tragedy struck a vital interstate crossing,
People were frozen, thinking that the ship was going to stop.
leaving drivers fearing for their lives.
We tried to warn them to run, and you could feel it drop beneath your feet.
Revealing a weakness that was hiding in plain sight for years.
When the ship struck, there was nothing to stop the bridge from collapsing.
Brunswick, Georgia, on the Atlantic coast of the US. The city has thrived thanks to a location that has made it a major hub for shipping. Sandy White is a local historian.
So there have always been a lot of ships coming in and out of the port of Brunswick. We've actually been a US port of entry officially since the 1770s. During World War II, we had the Liberty ships that were built here in the city.
Brunswick is a perfect location for a port, with 2 islands sheltering it from the Atlantic Ocean, as well as great connections with inland waterways, railroads, and interstate highways.
Every ship sailing in or out of Brunswick passes beneath the Sydney Lanier Bridge, Georgia's tallest cable-stayed crossing and key to keeping the area on the move. Hank Staley lives nearby.
Sydney Lanier Bridge connects Brunswick to I-95. So without that bridge, there's an extra 20 miles or so out of the way.
But this isn't the first crossing to span these waters. Its predecessor might have had the same name, but it was a very different bridge.
The first Sydney Lanier Bridge was finished in 1956. It was a lift bridge.
The bridge had 2 outer sections, made up of steel spans to carry vehicles from either shore towards the lifting section.
The central lift was raised on the Sydney Lanier and traffic was stopped for shipping traffic to allow them to go underneath.
For the next decade and a half, people waited in their vehicles as they watched hundreds of ships slip through the opening.
There's heavy traffic through that bridge. So if you have to travel that route routinely, then you're going to frequently encounter the draw span being raised.
Little did waiting drivers know, but this engineering triumph would soon come crashing down. Tuesday, November the 7th, 1972. I-95 was busy with vehicles crossing the Brunswick River.
It was a night just like any other night. You have people traveling back and forth across the bridge.
Just after 8 p.m., an 11,000-ton cargo vessel was leaving the port of Brunswick, heading for the Atlantic Ocean. Hank was a student at the time.
So I'd been to school that day, and I was with one of my buddies, and we were on our way back to Brunswick.
Hank decided the quickest route was straight across the Sydney Lanier Bridge.
As we approached the bridge, the barriers were down, which indicated the span was about to lift. Another friend was parked immediately in front of us, and we said, let's get out and speak with him.
In the darkness, dimly lit by the bridge lights, commuters were waiting for the ship to pass through the opening. But something wasn't right.
The boat, we glanced at it, it was several hundred yards away at the time, but you could tell it was not where it was supposed to be.
The ship was off course and heading straight towards the span with Hank and his friends on it.
Panic started on the bridge as people realized that the ship was not in fact going to go underneath.
The 3 of us started running down the bridge. We knew we had to run as fast as possible to get beyond where the ship was going to hit.
As the massive ship loomed large, Hank and his friends ran for their lives.
Some people were frozen in their vehicles, thinking that somehow the ship was going to stop.
We tried to warn them, the boat's going to hit the bridge, get out of your car, run. We absolutely could not stop running.
Hank made it just in time. At 9:49 p.m., the ship plowed into the bridge, forcing 3 spans into the water, along with vehicles and their passengers. Shocked and shaken, Hank and his friends witnessed the devastation.
Everybody, with the exception of 4 of us, were in their car. So it had to be a terrifying experience to fall from that bridge.
It was immediately clear that there was going to be a major rescue effort to save the lives that were now in jeopardy.
In the darkness, rescuers pulled 11 injured people from the water. But the following day, divers found 10 victims, still in their submerged vehicles.
If I had not been outside my car, whether or not we would have survived that, who knows?
For 15 years, people had sat and watched ships sail through the channel. And after this tragedy, they wanted to know, was the danger there all along? Federal investigators began by examining why the ship was off course. It seems an order had been given shortly before the collision to line the vessel up with the shipping channel. Bridge engineer Adel El Safdi knows the case.
They said that there was a rudder order that it instructed the ship to go to a certain direction. It went in the opposite direction. And there was delay in noticing the error.
This was an 11,000-ton ship. By the time the error was noticed, it was too late to alter course or to stop this massive vessel. The consequences were devastating.
The report cited a series of unfortunate events on board the ship. But investigators also concluded that issues with the bridge had contributed to the loss of life.
The outside spans of the Sydney Linear Bridge are made of steel eye girders. They are vulnerable to any transverse hit or force by a vessel or a ship, and they don't have that much redundancy.
The reality is, few steel and concrete bridges like this could withstand a direct hit from a ship weighing 11,000 tons. In fact, engineers had factored this vulnerability into the way the bridge would operate.
The 50-metre-long inner spans beside the shipping channel had been designated as buffer zones to be kept clear of waiting vehicles. But here, the vessel was so far off course that it took down 3 spans.
None of the superstructures are designed to sustain an impact and collision by a vessel or a ship.
This wasn't the first bridge to be taken down by a ship, and it won't be the last. But with each disaster, engineers are learning lessons to help keep bridges of the future safe.
In the wake of this disaster, federal authorities passed legislation to prevent traffic from waiting on bridges that were vulnerable to collisions like this.
Despite the vulnerability, the bridge was a crucial connection for this part of the country, and so authorities began to rebuild.
It was so important to have this bridge here over the Brunswick River. It took around 6 months for them to complete a rebuilding of the bridge.
But the weakness exposed by the tragedy hadn't gone away.
Unfortunately, that bridge was hit yet again in the 1980s by another cargo vessel. Thankfully, there was no loss of life that time.
In the decades since the bridge was first built, cargo ships had got a lot bigger. And the 250-foot or 80-meter wide gap created by the lifting span was seeming smaller and smaller.
In 2003, construction began on a new, much bigger span to replace the lift bridge. Its cable-stayed design removed the danger of a ship collision. Decades later, the approach span of the old bridge still sits in the shadow of its successor, a memorial to that tragic day in 1972.
They decided to keep this both as a mark of what was here before and also as a fishing pier for the local community.
With the new crossing, not only is the shipping channel significantly wider than before, but the bridge pylons are protected by rock defenses, making it much safer for both the transiting ships and the vehicles above.